Müəllim, biz 5-ci terman keçəcəyik bugün.
Sorry. Can you hear me, Nermin?
Yes, we will learn today chapter 5.
Okay, so I say this is chapter 5, but our fourth lecture, fourth topic. Okay, because the chapter 4 is not needed, it is not important. That's why we continue with chapter 5. Yes.
Okay.
So can you see the presentation right now?
Yes, I have a question. First lesson is lecture and second is seminar, yes?
Yes, that's right.
Okay, I'm ready.
Lecture. Okay, I just shared the presentation. Does everybody see the presentation?
Yes, I see.
Yes.
Okay, very nice. As you see, this is chapter 5. The name of the chapter is The Economics of Environmental Quality. Just a minute. When I share the presentation, can you see me or you see only the presentation? Can you see me on the screen?
I see you and presentation.
Okay, very nice. Yeah, let's just continue. And the name of the chapter, The Economics of Environmental Quality. In this chapter, actually in the beginning, I would like to say, it includes, let's say, several new terms, just like abatement cost, marginal abatement cost, marginal damage, ambient concentration, etc. So I will explain the meaning of these terms, and you should be careful. Maybe if you do not understand the meaning of these new terms, it could be a little difficult for you to understand the topic. That's why you should be careful. And if you do not understand something, let me know, ask me, and I will try to explain in easier words. If we are talking about environmental quality, the very first term that we should start this could be policy. So what type of policy we should choose, or the government should choose, in order to sustain environmental quality? There should be a policy, appropriate policy. In this chapter, in this slide you see policy questions. This is about about choosing the appropriate policy. As I said, because why we should choose the policy, based on that policy, then I mean, actually, it is done by government. Based on that policy, government can create strategy to sustain, to maintain quality of environment. So it says that one of the first is that of identifying the most appropriate level of environmental quality we ought to, or we should try to achieve. As I said, this is based on the policy. And after this, another is how to divide up the task, how we should divide up the tasks in order to achieve that policy. Generally, this is like introduction. So we need a policy, and after that, we should divide up the tasks in order to achieve or to reach that goal, to maintain the environmental quality. Okay, so this is about choosing the policy. After this, of course, the simplified model is needed. So now I will explain this. What does it mean, a simplified model? Generally, let's just start with the explanation of a simple model. If we are talking that we need a policy to protect to sustain the environmental quality, it should be based on the policy. Based on the model. There should be a model, and this generally each model, involves, or let's say consists of trade-off situation. And by the way, in our previous lesson, we talked about the trade-off situation, if you remember. And today I will explain the meaning of that. What is trade-off? Let's firstly talk about trade-off. If you remember, I said that trade-off means we have, let's say, several alternatives. Let's say we have two different alternatives, and then we should choose one of them. In this case, if we choose one of them, maybe we will lose another one. Actually, it is similar to opportunity cost, right? I think in our previous lesson, Nermin said that I think this is very close to opportunity cost.
Yes.
Right? So,
Yes.
Nermin, do you remember the definition for opportunity cost?
Opportunity cost is loss of other alternatives when one alternative chosen instead of another.
Exactly. Very nice. Loss of other alternatives. So this is a trade-off situation is quite similar. We have several alternatives.
They're equal or different. What's their difference?
What's the difference? So difference is that this is not opportunity cost. This is just a term that we will use. You know, you can use this term, the trade-off, in different situations. Maybe it's not about related to economics, environmental economics. You can use this is so there is a word in English, compromise. Do you know compromise? Actually, in Azerbaijan, yes. We use this word, compromise, right? So. Yes. So this is similar. If we are choosing different, try to choose or try to make decision between several alternatives, and when we choose one of them, and after that we will lose other alternatives, we can say this is a trade-off situation. But idea with opportunity cost, idea of opportunity cost, and this trade-off situation is the same. But generally, two different terms. Opportunity cost, this is a type of cost. We talked about it, which is used in accounting and finance, in environmental economics. But the trade-off situation, this is a general situation that you choose between you make decision between different alternatives. Okay, I said that we will talk about the simplified model, and a model is required when we are, let's say, maintaining, when we try to choose the policy to maintain environmental quality, a model is needed, and this model will be based on the trade-off situation. Each model, let's say, involves a trade-off situation. Says that diverse types of environmental pollutants call for diverse types of public policy, and to build up the required policy analysis, it is better to start with one very simple model that lays out the fundamentals of the policy situation. Okay, let's continue with trade-off situation, and I will explain this model. I will continue to explain the model. So trade-off situation. On this slide, you can see some more explanation for trade-off situation. As I said, each model involves or includes trade-off situation. And trade-off situation, this is like opportunity cost, loss of other alternatives when one alternative is chosen. The essence of the model consists of a simple trade-off situation that characterizes all pollution control activities. Okay, now you can ask what is the trade-off situation in the model, in a simple model. So now you will understand it. Here we have, just like an example, reducing emissions. What is emission? This is just like pollution, right? Reducing emissions.
Emission. It is, yeah.
Emission. So this is like a pollution. Okay, pollution in atmosphere. It is called as emission. Is this clear, Nermin?
Yes, yes.
Yes, this just like pollution on atmosphere. This is called as emission. So reducing emissions reduces the damage that people. So this is a trade-off situation. Please be careful. says that reducing emissions reduces the damage that people suffer from environmental pollution. Reducing the emissions reduce the damage that people suffer from environmental pollution. But what's the trade-off situation? At the same time, reducing emissions takes resources. If we try to reduce the pollution level, it takes resources. What are the resources? It could be time, energy, money, some other technical resources, technologies, etc. So reducing emissions takes resources that could have been used, but you could use these resources in some other way. That's why this is a trade-off situation. So firstly, let's say you want to reduce emission. It says that reducing emissions reduce the damage that people suffer from environment. Okay, you will reduce the damage level, but at the same time it takes some resources, and so this is like loss of alternatives. You could use these resources in some other way. That's why you should make a decision between different alternatives. This is like a trade-off situation. Are you going to let's say use some resources and to maintain environmental quality, or to use these resources in some other way? In every simplified model in let's say environmental economics, every simplified model includes this type of trade-off situation. So generally you can say that the models, simplified models, are based on the different trade-off situations. And our goal is to maintain or sustain environmental quality. Okay, this is like trade-off situation. I think it is clear. Is this clear to you? What does
Yes.
trade-off situation mean?
It's clear.
Okay. Yes. After this, okay, this was first term. We started with the trade-off situation, model, policy. After this, we have another trade-off situation example, but this is an exact example, let's say specific example. Consider a simple situation where a firm is emitting production residuals into a river. This is just an example, okay? Just consider a simple situation where a firm is emitting production residual. What's production residual? This is the waste from production process. Just let's say a firm or factory is emitting production residuals into a river. So what happens in this case? As these residuals are carried downstream, what does it mean? Downstream we say that the firm is emitting production residuals into a river, and it will be carried downstream in the river, those residuals or waste. They tend to be transformed into less damaging chemical constituents in the river. But before that, so this is this is the first part of trade-off situation. It says that those let's say the harmful particles will be transformed into less damaging chemical constituents. Just it will be, let's say, transformed small particles, and it will not be, let's say, harmful for environment anymore. So it will be transformed into less damaging chemical constituents, but before that process is completed, the river passes by a large metropolitan area. What is a metropolitan area? So this is like urban area, population is quite high. So it says that before that process is completed, the river passes by a large metropolitan area. So this is the trade-off situation. Okay, the factory, that firm just tried to, decrease the level of that residuals. It would be in this. That's why, just that firm is emitting production residuals into a river, but at the same time, that river will pass through metropolitan area, which will be damageful or let's say which will lead high level of damage for the urban area that I say population is high. So one side of the trade-off is the damage that people experience when the environment is degraded. This is the, as I said, just like the urban area, one side of in that area, people live there, and one side of the trade-off is that, in this case, the damage that people experience. But other side of this trade-off situation is that those harmful particles will be transformed into less damaging parts, less damaging, let's say, chemical constituents. Okay, so there are too many, I see there are too many, new words for you, but generally so this example has been taken from the book, but important thing is that to understand the idea. What does trade-off situation mean? As I said, here we have two different alternatives, and in the previous slide also we talked about the alternatives. One of them can be chosen, in this case by the firm or factory. Okay, after this, yes, another term you should take note, especially related to abatement cost. I would recommend you to take some note. What is abatement cost? This is the cost that we will use during the semester, just like marginal cost, opportunity cost, and then abatement cost. After this, damage cost, etc. Also, we will talk about enforcement cost. So just by the way, I would like to ask you, does anyone remember what is that enforcement cost? Not from this course, but from other course, maybe you can remember. What is enforcement cost? Any idea?
Could you repeat, please?
Do you know, Narmin, what is enforcement cost? Enforcement.
No.
Okay, that was just interesting for me if you have heard about it in other courses, but generally right now it is not important. I will just continue and explain it. So now just a moment. I'm still a little unhealthy. Yes. Okay. How many students participating in the lesson? How many attendees are there? Eight students participate, right? I think there are nine. There should be 9 students, and we have 8 here.
I see in here.
Only one student is not here.
Yes, maybe it's Elvira. She's Elvira.
Elvira.
Yes.
Okay, will she join, or do you know something? Will she join, or
she has some problems or anything else? I don't know. She can't join. Only.
it is not important. Yes, it's not important. So, in the end of the lesson, in the end of the first hour, I will just put some absence, or if everybody generally participates, so then it's not a problem. Okay. So now, can you see the presentation? Abatement cost.
Yes.
Okay, so in the beginning, what is abatement cost? Abatement cost is the cost of reducing environmental pollution. Just please take note, because it is important. You should remember. In the lesson, in the class, next lessons, I will ask you again to all of you students. Abatement cost is the cost of reducing environmental pollution. So in order to reduce environmental pollution, so we should spend some money, just simply. This is called as abatement cost. Generally, it is spent by firms or factories. So abatement cost is the cost of reducing environmental pollution. So again, we will continue with another example. So it is just interesting for me. Does everybody listen to me or not? I'm talking with Narmin, so I'm sure that Sebastian is listening. What about other students?
Good morning. I do listen.
Okay, okay. Gülzar, what about you? Can you hear us, Gülzar?
Yes, I am here.
Okay, okay, very nice. So now we can continue. Abatement cost. Yes, so we said that abatement cost is the cost of reducing environmental pollution. We have an example here. The pulp mill. Okay, so you will ask, what is pulp mill? So pulp mill, this is like a technology to produce paper. Pulp mill, for example, pulp mill factory to produce paper. The technology to produce paper. Okay, so the pulp mill could reduce the amount of effluent by treating its wastes before discharge. Treating its waste, it means just simply a recycling. So it says that this technology, this pulp mill, could reduce the amount of effluent or amount of pollution. Let's say effluent. This is like pollution, but when we say effluent, this is pollution, but it is liquid. Yes, but not like a substance, but liquid. For example, in the previous slide, we said that the chemical particles in the river, that type of pollution in the river, this is effluent. So the pulp mill could reduce the amount of effluent by treating or by recycling its wastes before discharge. In this case, what is abatement cost here? So this type of technology, as I said, to treat the waste, treating it as waste, it requires a technology. This is recycling process. So it takes some cost. It creates some additional costs because this recycling process actually will reduce waste in the environment because this is recycling. And that's why it, as I said, it brings additional cost. This cost is called as abatement cost. So we said that abatement cost is the cost of reducing environmental pollution. In this example, this is about treating wastes or recycling wastes, which will be used in paper production. Okay, so generally, I think the idea is clear for you. In this case, the abatement cost. So let's continue this slide, and it says this act of reducing or abating some portion of its wastes will require resources, and the costs of which will affect the price of the paper it produces. So if it creates additional resources, what will happen in the end? Of course, it will affect to the price, to the final price of that paper, because so if there is not a recycling process in paper production, so it means there is not any, let's say, additional high technology. They are just producing and emitting waste, let's say, into the environment. And in this case, but this type of technology, just like recycling, brings additional cost, and this cost will be added to the price of final product. That's why this type of technologies maybe, as I said, will increase the price of the product. After this, these abatement costs are the other side of the basic pollution control trade-off. Again, this is like a trade-off situation. If that factory is going to use that new technology, okay, this is helpful. This would be really good for environment to protect the environment, but at the same time, it creates additional costs. So then we should make a decision, or that factory should make a decision, or the government can make that decision, which alternative should be chosen to use new technology for recycling, or but at the same time it will increase the price. So which one would be the best decision? So that's why this is another trade-off situation. Okay. Do you understand everything, guys, when I explain these new terms?
Yes, everything is clear.
Yeah, for me also.
Okay, very nice. After this, okay, here we have, yes, some damage functions. So firstly, these are the marginal damage functions. Generally, the shape of the functions will be the same. As you see, just like the marginal cost, it's increasing. It's always, there are some fluctuations, but it's always increasing like this. And firstly, what is marginal damage? Marginal damage is the damage caused by additional unit of pollution, just like the marginal cost. As I said, marginal cost is the cost of each additional unit of output produced. Marginal damage is the damage caused by additional unit of pollution. What about marginal abatement cost? So this is the cost of reducing each additional unit of pollution. So all of the idea is the same for all of them: marginal cost, marginal damage, marginal abatement. Because the marginal, this is about the marginal, the word. So I have explained the meaning of this word marginal. That's why idea is the same for all of them. Okay.
I'm sorry, marginal abatement cost is cost of reduces each additional what? Pollution?
Each additional amount of pollution. Yes. And marginal damage is the damage caused by additional unit of pollution. Yeah. So here we have so this is marginal damage. As I explained, marginal damage is the damage caused by additional unit of pollution. And here we have some marginal damage functions. So there are some differences in the shape, but generally all of them are increasing. What's the meaning of this? What's the reason of these differences? Because this is because of the, waste, the type of pollution. The pollution could be, let's say, dangerous for environment, or maybe it is not that dangerous. So that's why, if it is that pollution is very dangerous, let's say harmful for environment, it will directly affect the price of that damage, cost of that damage. Because here we have different functions. Each function on the left side, on the that vertical axis, shows us damage. This is cost of damage. And on the horizontal axis, emissions. This is amount. This is showing amount of emission. So this is tons per year. You can see in other functions, this is the same. Other graph, it's the same. So for example, below you can see two different functions, but in the horizontal axis, this is ambient concentration. Ambient concentration in ppm. What is ppm? This is particles per million. But this is also showing amount of pollution, but just it is measured based on particles per million. ambient concentration. What is ambient concentration? Okay, generally this term is used in chemistry. Concentration, for example, pollution concentration on atmosphere in, or let's say within liquids, just like the concentration, this is showing pollution level. So ambient, it means your surrounding environment. Ambient concentration, just another way of explaining pollution in environment. Okay, so here we have several damage functions, and as I said, the differences in these curves are based on the type of that pollution. For example, the first one, this is like increase. It starts very close to the 0 point and then increases. But the second one, it starts from the certain point on that vertical axis on the showing the axis showing cost. You can see, and you can ask why it starts from here, because so this could be, for example, very harmful. This type of pollution could be very harmful for environment. That's why even if it is just 1 ton, let's say, at the very minimum level, cost of this will be very high. For example, in the first one, let's say it starts from the point very close to the 0 point, and damage and emission level increasing at the same time. This is called as directly proportional. They are increasing at the same time. But in the second graph on the right side, you see that damage curve starts from the point on the vertical axis. That's why its cost is high. It's showing its cost is very high. Generally, idea is that these curves will differ based on the type of pollution. But all of them are called as marginal, let's say, yes, all of them are called as marginal damage functions. And the important another just definition here, I said this marginal damage is the damage caused by additional unit of pollution. Okay, now we can continue.
I'm sorry, in this second graph, it damages emissions. They're writing EBC. What's
yes,
it means?
LBS. This is it means pound. Pound. This is like kilogram. 1 pound equal to 0.45 kilogram. LBS. So we are not using this LBS or pound in Azerbaijan, but it is used in the United States. For example, Sebastian, are you using LBS or pound in your country?
No, we also have metric system.
Yes.
Like kilograms, yes.
Kilograms, yeah. I think in the United States they are using pound, if I'm not mistaken. So generally, this 1 LBS, this is 1 pound. It is called as LBS or pound, and it's equal 0.45 kilogram. Okay. Yes, now let's have a look at next slide. Yes, actually this slide explains the graph in the next slide. Let's have a look at that graph, and I will explain this graph in my own words. You can see this is figure 5.2 showing marginal damage function. So more explanation for marginal damage functions. We have two different damage curves here, MD1 and MD2. What is MD? Marginal damage. Here we have MD1, the first curve, MD2, the second curve. Simply, again, just have a look at the left side showing that vertical axis. This is cost level. This is called as damage cost. But on the horizontal axis, showing amount, tons per year, showing the just amount of pollution, amount of emission in tons. So then the first one, if you have a look at the first curve, MD1, marginal damage curve 1, what it shows us, in this case, the cost is a little lower or less than the cost of MD2. This is $12. For example, for the level E1, just have a look at that horizontal axis. Here we have a point E1. This is showing pollution level. Just it could be, let's say, 5 tons, like this, showing pollution level E1. In this case, cost of this damage, according to this graph, this could be $12 for the first curve. What about for the second curve, MD2? This is showing the cost is a little higher. This is $28. So this is showing just cost of the damage, as I said. But you could ask, what's the meaning of this? Why they differs from each other? Yeah, sorry, what happened? Yes. What's the reason of this? Actually, this is, these two curves represent different situations. For example, according to the book, when you read the book, you will see the first one. So this is like, let's start from the second, MD2, because the cost of the that damage cost is high. This is $28. This represents the damage cost of urban area. What is urban area? Narmin, could you say what is urban area?
Urban area
Urban.
Where people live. So,
Yes, that's right. Just like a city. So that's right. But what about rural area? Rural.
There not people live.
Yeah, people actually live, but the population is
Rare.
very low, rare. Yeah, that's right. This is rural, means just like a village, small village, let's say. Okay, in this case, the MD2, marginal damage function 2, shows the cost of damage or damage cost for the urban area, but MD1 represents the damage cost for rural area. What's the idea of this? If cost is high, it says that in the urban area population level is high. That's why people will suffer. In this case, people will suffer from that damage more than the people live in rural area. As I said, because in the urban area population is high, but in rural area less than this. That's why the cost would be different. So these two different marginal damage curves represents different situations, different areas, and you can understand it based on the cost level, right, on the left side. Always, if you try to understand the meaning of the graph, always have a look at the cost curve on the left side, vertical axis and horizontal axis. Then, immediately you will have an idea based on the cost, based on the amount, and then you will understand the meaning of that curve. If it is increasing, showing simultaneously pollution level and cost is increasing. So it should be, let's say, clear for you in this case what happens. Or if it is decreasing, this would be another situation. So abatement cost curve is quite different. It is not similar to marginal damage. In the next slide, I think you will see that abatement cost curve. This is marginal damage curve, but abatement curve is, I said, is different, and you will see.
I have a question.
Yes, what's that?
In here, MD second curve shows urban areas pollution, yes?
Yes, pollution
Okay.
in urban area.
And
That's
another shows rural areas.
rural
Pollution.
area.
Okay.
Yeah, represents rural area and that's urban area. After this, yeah, abatement cost. So I explained the meaning of abatement cost. Could you just repeat it, please? What is abatement cost? Is the cost of reducing? Okay, I will repeat it. Abatement cost is the cost of reducing environmental pollution, environmental negatives, or environmental pollution. This is abatement cost. So abatement firstly, just let me explain the word, just meaning of the word, because we will always use this. Directly proportional, inversely proportional. How do you understand this? Directly proportional. You know, you could use this. Sorry, you could use this not only in environmental economics, but in mathematics, in some other, let's say, technical courses. You could use this directly. Something is directly proportional or inversely proportional. If they, you know, two different things, they are increasing or decreasing at the same time, simultaneously means same time, at the same time. This is directly proportional. But one increase, another one decrease, this is inversely proportional. Just a simple idea, actually. In Azerbaijan, how do we call this? Directly proportional, inversely proportional?
Please, could you repeat again directly and inversely proportional?
So directly proportional, we have two different, let's say, it could be two different alternatives, one increasing, another one increasing. They are increasing simultaneously, but this is directly proportional. But inversely proportional, let's say one alternative increase, another one decrease, or one decrease, another increase. This is inversely proportional. Okay, in Azerbaijani we say düz mütanasip, ters mütanasip. Do you remember this?
Yes.
Yeah. Okay. So just keep in your mind this word directly proportional and the idea, directly proportional and inversely. So abatement cost, this is inversely proportional, but marginal damage, I was talking about the damage cost, that is directly proportional. And that's why the graph, the curve is like this. It is increasing like this. But abatement cost, so I will show you the abatement cost curve. So abatement costs are the cost of reducing the quantity of residuals being emitted into the environment, or of lowering ambient concentrations. And abatement cost normally will, so simply keep in your mind, the abatement cost is the cost of reducing environmental pollution. And abatement cost normally will differ from one source to another. This is also important. Abatement cost will differ from one source to another, because this is based on the type of pollution. That's why it differs. And the costs of reducing emissions, for example, here we have an example on this slide. The costs of reducing emissions of sulfur dioxide, this type of chemical, sulfur dioxide, so from the chemistry you can remember this. The cost of reducing emissions of sulfur dioxide, this is harmful for the environment, sulfur dioxide. So this is coming from electric power plants. It can come from electric power plants. It will be different from the cost of reducing toxic fumes from chemical plants. So cost of reducing sulfur dioxide and cost of reducing toxic fumes is completely different. What is toxic fume? Toxic fumes, so this what is this? In Azerbaijani, I can say atmosferde olan tüstü demekti, toxic fume. Okay, but so sulfur dioxide, so this is just, so it would be sulfur dioxide from electric power plant. Cost of this, of course, it's clear that it will be high than the cost of toxic fumes, reducing toxic fumes from chemical plants. So that's why, what's the idea here? Abatement cost will be different based on the type of pollution. In different situations, abatement cost can be high or low based on the again, type of pollution. So next slide. Even for sources producing the same type, this is related to the previous slide. Even for sources producing the same type of effluent, the cost of abatement are likely to be different. This is the same I explained in previous slide. Even for sources producing the same type of effluent, the cost of abatement are likely to be different. Okay, what's the reason here? The reason is technological feature. Because maybe they are using different technologies. One source is using relatively new technology, modern technology. Another one maybe is using old technology, which is more highly polluting technology. So that's why in this case, even for sources producing the same type of effluent, the cost of abatement are likely or will be different because technology also affects this. Technological features affects this. So what did you understand? It's interesting for me.
I understand that abatement cost of reducing environmental problem.
Yes. Okay, let's talk about this slide, Narmin. Says that even for sources, there are different sources, okay? They are producing the same type of, let's say, emission, same type of pollution. They are producing the same type of pollution. But the cost of, or abatement cost for this will be different because there are different, let's say, different factors affecting this. In this case, that factor could be technological factor. Says that differences in technological features will affect the abatement cost. For example, using modern technology, if the factory is using modern technology, maybe abatement cost in this case would be lower because that new technology enables to reduce pollution level with lower cost. But all technology actually does not give us this opportunity. That's why its cost maybe will be higher. Is this clear, Narmin?
Yes, it's clear.
Technology affects the amount of abatement cost. Yeah. This is also important. Okay, I'm asking the questions, mostly to Nermin, sometimes to Sebastian. What about other students? They do not join the discussion. So I just want to make sure that everybody understand. So by the way, actually, let me have a look at. So actually, I'm recording the class. I'm recording this video. Even after the class, you can watch it. Okay, you can download and watch it. It is possible. So everybody have
you
access.
You will send us video, yes?
You can download it yourself. So
okay.
Just, yes, you can download. It's possible. Just enter. You have access here, and just enter your lesson. Just click on the lesson, then you will see the video there. You can download it. Everybody in our university with that corporate email can download the video. Okay. After this, this is next slide. Also about abatement cost functions. Actually, this abatement cost functions is in the next slide. This one, slide 15. You can see here we have two different abatement cost curves. What is this? MAC, marginal abatement cost. Marginal abatement cost. So shape of the abatement cost or marginal abatement cost, it is clear that is the same. It will be always like this. You can see on the slide. But how was the damage function, damage curve? It was like increasing, starts from the 0.10 increasing from below to above. But this one, abatement cost curve, is completely different. That's because we say this is inversely proportional. For example, how do we understand this? Have a look at the horizontal axis, x-axis, which is showing amount of pollution. If the pollution level is low, abatement cost is high. I will explain why it is like this. If abatement, it would be interesting. Can someone explain it to me? Why this amount of pollution, if we say amount of pollution is low, just let's say this is 1 ton. Actually, we can put here different, let's say, numbers. 1, 2, 3, 4, 5, 6, 7, maximum 12 tons, let's say. The first one is 1 ton. If the amount is lower and this is 1 ton, abatement cost in this case would be high, and let's say this is $1,000. If amount of pollution increases, 2nd ton, then what happens in this case? Decrease, cost decrease. If pollution level increase, cost will decrease. This is inversely proportional. How do you understand this? It would be interesting for me. Can someone explain? Based on the definition, we said what's the meaning of what does abatement cost mean? Firstly, try to remember that definition. Then I ask the question. Can you explain this?
In here, if pollution level lower, cost of abatement cost will be high. Yes, it's about long curve. Yes.
Yes, pollution level is lower, but cost is higher according to abatement cost curve, marginal abatement cost curve.
Mm-hmm. And if pollution increases, cost will decrease.
Yes. Okay, do you understand the idea of this? But this is not marginal damage curve. This is marginal abatement. Could you repeat the definition for abatement cost curve?
Mm-hmm. Abatement cost is cost of reducing environmental pollution.
Yeah. So now in this case, what would you say about this? Okay, let me explain, and everybody, please be careful, because I explained this and in next slide, sorry, in next seminars, and next Thursday you will have this quiz 1, and in the questions you will see this type of questions. If you do not understand the idea, okay, you will not be able to explain it. In the next seminar, in the next hour, we will have, actually it's almost we completed the first lesson, right? Yeah, we started at 10:10, this is 11:07, almost 11:10. Maybe we will continue. Okay, we will continue this because it requires more explanation. And also in seminar, I will talk about your quiz. You should be careful. And just let me have a look at the attendees. Okay, 8 students attend here. Only Elvira is not here. Okay, I will write her name here. That's clear for me. Yes, see you in next seminar. And the time, this will be 11:30, right, Nermin?
Yes.
Yes, 11:30.
Next week bize 4. bölümde ders kalıp.
Yok, now we have seminar today. Lecture, seminar, right?
Yes.
After we have 20 minutes break time, then our seminar will start 11:30.
Yes.
Okay, see you there.